Hi, how are you? Our lecture has been started. Are you ready? Today, I selected a chapter which is electricity of 10th standard. Whatever will be covered, all those points are here which are written here. Electricity current, circuit, measurement of electric current, all these topics we will be covering into too much details. In too much details. Practically, we will understand this lecture as well as theoretically. But as you know, practically is more useful than theoretically. But combination of both will be powerful. Will be powerful. Now, first point you need to know is that our chapter is electricity. All these points, these are all those points that are important from this lecture that we need to explore. Our focus will be on the understanding of all these topics. We will start with the introduction of electricity. What is the meaning of electricity? And we will end up till the advance of this lecture. Now I think we should start. You have got that yes, these are topics, this is a lecture. Now I want to start. These are learning objectives. Introduction about electricity, electric current and circuit, measurement of electric current, NCT problem, then electric potential and potential difference. What's the difference between the NCT problem? Again, electric circuit diagram. All this will be mentioned in this slides. Now we have started with introduction of electricity. Here, what happens when you touch a broken wire and electricity is flowing? Here, this is a broken wire, and here electricity is coming from here like that. But this is broken. Now, what will happen when you will touch this necked wire? Then what will happen? What do you think? Of course, you will get shock. You will get shock because you are conductor. What is a conductor? We will see. Here, this light, this electricity is coming. It is a continuum. When you will touch this thing, then you will get shock. You touch a broken electric wire. So answer is what? You feel electric shock due to flowing of electricity through your body. Electricity. When you will touch this electricity, then this will be continuous still inside your body. So what is happening here? Electricity is coming like that, and then it is a passing throughout this body. Then it is going like that. This is how it is traveling. This electricity is traveling. Here you are conductor, remember. Here you are not insulator. There is an insulator, then insulator will not conduct electricity. In details we will understand. Don't worry. Here you are getting shock because of reason is that you are conductor. That is what is reason behind it, behind happening it. Now, you must be aware of the fact that light in homes work on electricity. Yes. If we use a small electric cells, a small battery in our home for bulb, for a computer, for advanced devices, then it will not work at all. If you use a small electric cells, a small electric battery, then it will not work anyhow, because these electric devices are not made for advanced devices. We will have to use this type of electricity that comes from transformer. Now you are aware that whatever we see, glowing of light, we see uses of a computer, all this happens because of electricity, all this happens on electricity. Now you have now. Now next, what is electricity? Still we have this question. We have a still question. Exact what is the meaning of electricity? Let's us try to understand. We took two wire, this one and this one. What is happening here over here? When we will touch this two wire to each other, then what will happen? This will happen. This will happen. Both are enemy. Both are enemy to each other. And you can see what is happening, fighting. We can clearly say that yes, both are working. Electricity is working. Electricity is flowing through the wire. This is what we are observing. Now electricity is controllable. Where to control? Where is it control? Where is electricity control? Electricity is controllable and convenient form of energy. We can control this. We have a powerhouse where electricity are controlled. Yes, we can decrease the voltage of electricity. We can increase the voltage of a spirit. All this can happen on powerhouse. And this what is happening? And this what is happening? What is happening? If there is a sunlight, there is a sunlight outside the house, then what will happen? We don't need to glow the bulb because of we are getting sunlight. But what if we are in a night? Then what will happen? We need to glow the bulb. We need to glow the bulb, and it will happen when we will use electricity. So this is the use of electricity. This is the importance of electricity. Without electricity, there are a lot of work which will be incomplete, which will not be done without electricity. There are a lot of work that are depend on electricity. There are a lot of. Next, when the sun disappears, then we see what surrounding us. There are dark. Everything is dark. For see anything object, we need what, a light. And for a light, we will have to use what, electricity. And electricity will come from where? From powerhouse. Because powerhouse controls on off of the electricity is who? Powerhouse. When the sun disappears, we switch on the light that glows up our home. By switching off, we are saying that yes, we don't need glowing bulb. We can see anything without glowing bulb. We can control it, or switching on, switch off to switch on. This is the control. However, there is not only one use of electricity. Yes, I have told you that there are a lot of uses, Even you can, I can give some uses of electricity. First, your battery, your mobile get charged because of electricity. Bulb is glowing because of electricity. Computer is used when electricity will be passing through your device. There are a lot of electric devices that need electricity. These are some examples. There are a lot of examples of uses of electricity. Now, it has a variety of uses in homes, in schools, in industries. And in industries, you will realize what there are more uses of electricity. People are using more electricity in industry. In a school, less. In home, more less. In hospital, more electricity. These are some places where we can directly see uses of electricity, importance of electricity. Directly, I am saying. Apart from these places, there are more places. There are more places where we can realize importance of electricity, use of it. In hospital, we see all this happening. This device is working. All these devices are working because of electricity is flowing through this device. That's why. Inside the home, we see there are a lot of bulbs, fans, computers inside a home, and all this works. All this work when electricity is flowed, and this is a transformer here. Here electricity travels, and by this transformer there are a lot of transformers which control the voltage of electricity. About it we will explore in the next slide. We have some electric devices which can be used by using electricity. Without electricity you cannot use this. You cannot use this mercury. Without electricity even you cannot use AC, this digital board. What is it? I think I am not clear. What is it? This fan is also works on electricity. In our homes, a television, air conditioner, water heater, fans, so on also need electricity to function. Yes, to function all this need electricity. Without electricity, all this will not work at all. We are aware of it already. Okay. All these are devices that need electricity to function to function it. We understood we understood uses of electricity with real life examples. Now here laser light and even a small flashlight also works on electricity. But this we have this torch. This torch needs less voltage. For less voltage we can use only this. Less electricity we can use this electric for less voltage. Clear? So the electricity has an important role in modern society. Yeah, here, this is urban area. You can see bulbs are glowing. Can you imagine how much electricity are being consumed by this town? More. This imagination is beyond of your thinking. By this figure, can you realize that yes, electricity are being used more in the world? Of course. Are you able to observe importance of electricity? Yes, by this figure. Now, there are two forms of electricity. Forms. We have two forms. First is a static electricity and second is a dynamic electricity. Static which means rest and dynamic which means in motion. Dynamic motion. If electricity is in a rest, means it is not working. Otherwise you can say the speed is a constant. You can say speed is a constant. If this is happening, you can say electricity is a static electricity. We are talking about the types of electricity. You can say, you can consider it as that we are talking about types of electricity. First we have static electricity and second we have dynamic electricity. In this case, what is happening? Static electricity is where this Electricity, static electricity, which means charges, ions, electrons. Electrons are at rest. Electrons are at rest. If electrons will be at rest, of course, it will not work. It is not traveling. That's why bulb will not glow. Devices will not work. Now, in this case, devices will work. Electricity will flow. It will travel. Charges will travel because we are talking about dynamic electricity. We are talking about dynamic electricity. Dynamic, which means charges are in motion. This is the meaning of a dynamic. Charges are in motion. Clear? It was just a little information about static electricity and dynamic electricity. In too much details, we will understand. Don't worry. Just have a passion. So let's try to understand about the term static. Okay. Do you know what does the term static mean? In our language, we can say rest. Static, which means rest. Charges are in rest. This is what is the meaning in our language. Now, the term static means stationary or not moving. Yeah, we are familiar with this word. Nothing is moving, is static. In more standard, we can say charges are not moving inside the conductor material. This is the standard meaning, you can say. Charges are not moving at all. Rather, all these charges are in a rest. Okay, crystal clear about it. Now, here, with example, we can understand the meaning of a static. The term static means stationary or not moving. You can see the ball. This ball is at rest. It is not moving at all. We can see clearly what is the position of this object. This position of this object is telling us that it is not moving at all. Can we say it? Can we say this? Yes, we can. We can see the ball is not moving at all because it is at rest. It is at rest. Meaning of this example of this is similar with the electric charges, with the static electricity here. Hence, static electricity means that the charges are not moving. These charges, ions, electrons, all these are charges. All these charges are not moving at all. This is what is a static electricity. This is what is a static electricity. Is that clear? Now, lightning is an example of a static electricity. This lightning is an example of static electricity because it immediately falls and it has what? When it will fall down the earth, then there will be impact of this charges, and it is all these charges are in range, and we can see impact of this in real life. This is an example of a static electricity. It works, but after working, this will not. What I am saying? Once time it will work. Now, let's discuss about the charges. What are charges? This is also necessary to understand it. Electric charge is a physical property of matter. Physical property, not invisible. That causes it to experience a force when kept in a electromagnetic field. Okay. Through example, we will understand it more. We know that there are two types of charges, positive and negative charges. Ion and what? First positive charges, this positive, and next negative charges. These are only two charges. These are two charges. Here, Thinking about a magnet or a magnet, when we bring two poles close to each other, they get repaired. If this is both are same, then what will happen? Then they both will not attract. This both will repel to each other because signs are same. Meaning of this is the same with charges. If charges are same in front of to each other, then what will happen? Both will repel to each other. Here we can see. Here, what are we observing? We are observing that this sign hint at this in, in front of this, in front of them are different. In that case, if signs are different, you can directly say that yes, both will attract to each other. And this will happen with also charges. If charges are different and both are in front of to each other, then charges will attract. Okay. Similarly, like charges repel each other and opposite charges attract each other. It happens also with the charges. Opposite charges, here you can see. This opposite charges. What is happening? Both are different and both are attracting to each other. And here in this case, same charges, but both are not attracting to each other. Both are repelling to each other. This is the nature. Let's note this. This is nature, okay? All this happens. Who actually carries these charges? We know conductor. These charges is carried by tiny particles which have a small mass. They are called subatomic particles. There are particles which carry what? There are particles which carry what? Ions, charges. Here you can see we have this subatomic. This is atomic, but some atomic piece of atom. They carry charges. When electricity is flowed inside the through the uh, conductor, then it works. It travels. All some atomic particles start traveling when electricity is followed. Now you have studied about the structure of atom in previous video. Here we have a subatomic atom. What is happening here? Basically, atom has a nucleus which contains two types of a particle, proton and neutron. Proton and neutron. Atom has a nucleus. This atom has a nucleus. This nucleus which contains this place is a nucleus. Here this place will contain two types of particles. One proton. This yellow color is a proton, and without yellow color is what? Neutron. This is neutron and this is proton. And nucleus is a place where both are both are particles here. These are protons and neutrons. Nucleus is a center, and these protons and neutrons will be here, and these are atoms. You will see use of this, don't worry. Proton is a present in a nucleus, so it is not able to move. Proton, here we can see proton and neutron both are attached to each other, and here proton is not moving. Alone proton is not moving. Proton is present in a nucleus, so it is not able to move. Now, proton has a positive and Neutrons will be negative. Can you say proton has a positive electric charge? Proton here. Here we can see this proton has positive charges, but electron has negative charges. Where are negative charges? These are negative charges. These are negative charges which are moving. Remember, positive charges will not move because it is in nucleus. It is present in nucleus. These are protons. Protons are positive charges. Protons has a positive electric charges and neutron has no charges. Neutron has nothing. Neutron has nothing. Remember, neutron has nothing, but proton has a positive. And this blue is a electron which has a negative charges. Here, one more type of particle, one more, which is electrons. Electron. This is a third particle. This is third atom. It will contain negative charges. One more type of particle contained by atom is called electron. Exists outside of this nucleus of a nucleus, and it is a free to move. Yes, we can say this is a free to move. We can visualize it. These are electrons which are moving, and proton and neutron are not moving at all because both are present in nucleus. And proton has positive charges, but it is not able to move. Electron has negative charges, it is able to move. When electricity is flowed through the inside the conductor, then electrons work, but protons no. Clear? Electron has a negative charge, negative electric charges. Yes, we are clear now here. So we can say positive charge is what? Proton. Negative charge is what? Electron. Yes. Proton positive charge is carried by a particle called proton, and negative charge is carried by a particle. Particle is a proton. Particle is an atom, and that atom contains what? Electrons. We have three types of atoms. One type of atom only contain positive charges, and the second type of atom only contains what? Negative charges, and third nothing. Neutrons nothing. Remember, neutron will be present in nucleus, and this work of this is nothing. Just it is present in nucleus. Now, the negative is carried by electron. We are crystal clear about it. In this chapter, we will discuss about dynamic and current electricity. Our focus, our more concentration will be on the discussion of dynamic electricity. Dynamic electricity. Remember, clear? On a dynamic electricity. Do you know what is a dynamic electricity? Electric charges are in motion, then they are dynamic electricity. Do you know what does the term dynamic mean? Dynamic dynamic means motion of a something. We are in the context of electricity, so here we are saying motion of charges. Charges are moving. Charges are in motion. Now, here these are charges. Can you say which kind of charges are moving? You would say electrons. Proton does not move. Neutron also move. Only electrons move. Electron has a negative charges, and only it moves. Whenever you are saying dynamic electric charges, you are saying that electrons are moving. Electrons will be moving. Now, in dynamic electricity, charge does not remain at rest, or charge is moving. All these charges are moving. Here we can see This is what is a nucleus. Here we have protons, and this is working like that. This is working like that. What is happening here? Oh. So what did you understand from this slide? You understood that yes, particles are motion, then this will be dynamic electricity. That is what you understood. We will discuss about the dynamic or current electricity in next video. Okay, no problem. So right now we have equations. I think no about electric current and circuit. We are going to explore it. So have you ever heard about the term current? Oh my god, current. Current. Current is what? Electricity. Let's visualize it. This current. Electrons are moving. Is a current. Electrons will be moving, will be current. This is what is the current. Generally, when we hear this term, one picture appears in our mind. Is this? Is this? We say that I got current, I got shock. Current, which means particles. Electrons are moving. This is a current. But it is termed as electric current, not current. Electric current. Current, which also means right now, today, current affairs, like that we say. But when we add electric with a current, then this is the complete meaning of electric current, whatever we want to say in this chapter. So electric current, not current. Clear? Let us try to understand the general term current and the standard term electric current, and we try to understand electric current. First of all, current. Okay. Here we have this. We are familiar with the water current. Yes, of course. We are familiar with the water current, air current, and electric current. We are familiar with this. This is what air current. This is water current, and this is electric current. What is happening? All these are working. All these are working. This is what we are observing. Let's talk about water current first. Okay. Here what is happening? When you see the river, it goes very fast, so we can say the water has a current. It has a what? Faster effect. You can say it is moving. Water has a current in the particular direction. It can be opposite current, it can be straight current. Is it moving slow or fast? You say by saying current. Here we can say here, if you put this shoe in the river, it will pull in the river and you can feel the current. You feel that fastness of the water in the river will be what more when you see like that view in your area. Here you will say yes, current is more. If you zoom the water current, water current, then what will happen? You will find that there is a small water molecules. They are moving in such a direction like that, in wave. There are a small, teeny molecules which are working like that, which are moving like that. Here we can see this like that, this way. It is happening like that because of molecules. There are at some places molecules are more, at some places molecules are less. That's why this is happening. Now, okay, till here we are. you will find that there is a small water molecule, they are moving in such a direction like that. Okay, clear? So the water current is a follow of a large number of water molecules. Here we have a lot of molecules of water. That's why the current follow is a more. Follow of water is more because of there are large number of molecules. That's why we can see follow of water is a more. Let us talk about electric current. Electric current. Same here we will learn, but fastness, a speed of electricity. Here we have seen that water current is due to follow water molecules. Due to, and in this we will realize that electrons are more. We will see what electrons are more. If electrons are more, then we would say current is more. If electrons are less, you would say current is less. Electric current is less. Let's visualize. Here, similar electric current is a follow of electric charges. Yes, we saw that water current is a follow of number of molecules. Similarly, here we have charges, electric charge. Here, this blue color is a electric charge, and this red color is what proton, nucleus, protons. All these are working like that. Okay. Similar electric current is a flow of electric charges through conductor. This is a, let's say this is a conductor. Inside this conductor we zoomed it and we are observing, but there are a lot of protons and this much are numbers of electrons. It is working like that. What if we have more number of electrons? Then what will happen? Let's also try to understand flow of a charge with the help of a working of the torch light. Okay. Here, this in a torch, we know that these cells or a battery, when placed in a proper order, provide a flow of charges or an electric current through the torch, causing the bulb to glow. Let's visualize it. Here we can see these are what particles. We can see a speed of charges. When switch is on, then the cell provides the flow of charges or an electric current through the torch bulb to flow. If a switch is off, here we can see if a switch is off, then it does not work. Then it will not work. The current does not follow and bulb does not glow. Yes, we know. Bulb will glow when charges will be, when electric charges will work. Now next, what does a switch do? It breaks the complete circuit of electricity, or it completes the broken circuit of electricity. This is what is the work of a switch. We said that this is work of electric switch, and we can control the electric circuit by using a switch. It gives us a protection. This is a safety device. Switch is considered as a safety device. What does a switch do? Let's see. Actually, a switch makes a conducting layer between cell and bulb. This is a switch. What is happening over here? This is bulb, and here this is electrons. This is the direction of electrons. It starts from negative. It will start traveling like that, then like that. What is happening? When it is attached to this, then it starts glowing. But it is not attached to this, then it does not glow. All this happens here. When it is open, it means this electric circuit is an open circuit. When it is attached to this, then it is a closed circuit. Clear? No. Now, if this circuit is a broken, if a circuit is a broken circuit, yeah, I told what here I told if this is open, it means circuit is open, but it is closed, then it means circuit is closed. Circuit electric circuit is closed, then bulb will glow. Electric circuit is open, then bulb will not glow. Because reason is that in this case what is happening, electrons are coming from here, electrons are coming from negative terminals, and it is going like that, but it is not able to pass this gap. To pass this gap, we need a requirement which should be conductor, and those conductors should be attached with this. But here we can see this is broken. How can they travel? No, without any attachment. So they are traveling to till here. That's why it is not it didn't go to till here. That's why it will not go at all. So this type of a circuit, we considered it as a what we considered this type of a circuit as a open circuit. Now next we have a closed circuit. So we can say that a current follow through closed circuit or in a loop. Here we can, this is a closed circuit, nothing is broken. Confidently you can say me that nothing in this figure, nothing is broken. We can say all things are working very well. And we have some components. This first is a battery, this is a wire, and this is a bulb. And okay, here all things are working. Here we can say inside the wire electrons are working, inside the wire electrons are working, as you can see. And so here all this are traveling, so that's why it is a complete. So of course in this case this bulb will glow. A continuous and closed path of an electric current is called electric circuit. A continuous, yes, we have. You can say what is that? Parts of an electric circuit. Parts. This one part. There's a one part. There's a switch. There's a light bulb. There's wire. All these are parts that was used to make this circuit. Without two or more components, it is impossible to make a electric circuit. So parts of electric circuit are called electric components. These are electric components, yes. Here they are bulb. Here you can see they are bulb, battery, switch, wire. All these are electric components of electricity. Now we try to understand direction of the electric current. Okay, direction of the, we will see what direction. It will start traveling from the negative terminal, then it will end, not end, but it will visually we can see that it is ending at the positive terminal. Visually we can see, but we cannot 100% say that it is ending at a positive terminal. No. Let's visualize it. Now we are going to try to understand a direction of the electric current. Okay, mathematical form of electric current. Here we can say direction of this electric current, electric charges are how, like that, in this direction. Okay, so we can represent this direction in mathematics like that, as a arrow. Please note down it in your copy. Now here metallically wires contains free electrons in majority. Yes, if you have metals, if you have conductors, then they have free electrons. But when it will come to insulator, then you should be aware that insulator does not conduct electricity. Only conductors materials will conduct. So metallic wires contains free electrons in majority. All these are electrons which are in metal. We know that they are free to move if they are in conductor thing. So the current in the metallic wire is constituted by electrons. Okay. However, electrons were not known at the time when the phenomena of electricity was first observed. Here, so electric current was considered to be the flow of positive charge. Before a lot of students used to use to read this to say this that we have a flow of charges, but now we are saying current, electric current. Here we have this much charges, it will start traveling like that, and here then again. And inside this we have what chemical storage. If a chemical storage is getting in, then this will work slowly uh, with respect to time. If it is new, then it will work properly, work will be smooth. So electric current was considered to be the flow of positive charges, and the direction of a flow of positive charges was taken to be the direction of electric current. Here we can see uh, this is this is the direction of electric charges. This it is coming from positive terminal. So this is not a direction of a electron flow. This is a direction of electron flow, and this is what just opposite of this electron flow is what electric current. This is a direction of a electric current. But when it will come to when it will come to direction of electron flow, then you will have to say yes, this is going in this direction, so this would be direction. But when it will come to current, then just opposite of this will be direction of electric current. Clear? You are crystal clear now? Now, conventionally in an electric circuit, the direction of electric current, there in an electric circuit, the direction of electric current is taken as a opposite. Yes, we observed. We observe that electrons are moving in the direction, but we are saying that direction of a current is in this direction, just opposite of a direction of electrons. Here we can see this electron flow, and here we are saying this is current direction. This is current direction. Electron will start traveling from negative terminals, but direction of a current would be from the positive terminal till the negative terminal. Now we are crystal clear. Till here we are done. Figure shows the schematic diagram of a typical electric circuit comprising a cell or electric bulb, a flag key. This is a for you. What is happening in this case? Electron flow is in this, but current would be just opposite of this. Okay. Note that the electric current follows. Note that the electric current follows in the circuit from the positive terminal. Okay. Yeah, current follows. It is talking about current flows. So it will follow from the positive terminal till the to the negative terminal of this cell. Okay, we know direction of, yes, we are crystal clear. Now we are coming to the main point. If a net charge Q, we can represent this charge as a Q, follows across any cross section of a conductor in time t, then the current, we will represent current as a I and charge as a Q through the cross section and t as a time. What are we saying here? How much charges here, and this is the current. So charges upon time, this will tell you that this much current was followed. we will have some question based on this discussion. Electric current is equal to Q upon T. So Q is what? Q is the charges, T is the time, I is the electric current. I is the electric current. Remember. The SI unit of electric charge is a coulomb. The SI unit of electric charge, SI unit, we are talking about SI unit. We know that electric charge is represented by Q, but SI unit of electric charge is a coulomb. Coulomb. C. Do you know how many electrons make up a coulomb? How many electrons? Number of electrons we are talking. We are talking number of electrons. Number of electrons. So electric charge make up one coulomb. So here we know that an electron possesses a negative charge of 1.6 multiple 10 raised to power minus 19 C coulomb. This is one electron is equal to this much coulomb. Let us try to understand it by activity. Okay. Now we try to calculate number of electrons contained in 1 coulomb. In 1 coulomb we have how much electrons? Let's try to understand by activity. If a cost of a 10 chocolate is a 5 rupees, so for one chocolate one chocolate will cost how much? 2. Similarly, in this, we are saying one electron is containing this much coulomb. So one coulomb will contain how much electrons? With this example, we can understand meaning of that. How many chocolate will you get in 1 rupee? So in 1 rupee, you will get 5 to the 10. So in 2 rupees, you will get 1 chocolate. But half chocolate, you are getting half chocolate. You will get 2 chocolates in 1 rupee. What the hell? 10 chocolates is 5 rupees. 5 rupees. So here, if you will take 2 chocolates, we will get 2 chocolates. You will get 2 chocolates in 1 rupee. Yes. So here we are saying in 1 coulomb, how much electrons we will get? That is what we are saying here. We are saying that in 1 electron we are getting this much coulomb, but question here is that in 1 coulomb how much numbers of electrons will we be getting? That's okay. How did you calculate it? Just we divided 10 upon 5, and this will be done with also coulomb electrons. If the cost of a 10 chocolate is 5 rupees, then of course you will divide. Same here. We know that the charge contained by 1 electron is this much. 1 electron is equal to this much coulomb. That is what we are saying here. We are saying 1 electron contains this much coulombs. This much. It is not more, it is less. Actually, this is less. 1.6. Hold on. Let me find a calculator. 1. Where are you? 1.6 multiple 10 raised to power minus 9. So this much coulomb. This much 0.00016. 1 electron is equal to 0.00016 coulomb. This is not more numbers. This is very less. You can see. So here we have what? So 1.6 multiple 10 raised to power 19. Hold on. How much? 19. So it should be 19. Now here you can see we are getting this 1.6 a minus this much. It is a more or less. Can we say this? Can we say multiple? Multiple. Where is the multiple? This multiple. 10 multiple. Not 10 yaar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, here this much. It is a, I think it should be too much less. We are saying that it is a too much less. This number is a too much less. That is what we are saying. Here we will use a formula. Here we will use formula. So the how many electrons contains by 1 coulomb of a charge? How many? For this, 1 electron is this much. Yes, we know 1 electron this much. So to solve it, 1 coulomb is equal to 1 upon. So Q upon this coulomb. This. So it will give us what? Electron. It will give us electron. We have this. So divide by no, here divide by 1. 1 divide this much. So here we will get how much? This much electrons. It is equal to this. 1 coulomb is approximately equal to this much electrons. We are getting this much electrons. One coulomb. 1 electron is equal to this much coulomb, and 1 coulomb is equal to this much coulomb. This 1 coulomb is equal to this much electron. This much 6.24. It is not a small number of electrons. It is more a small number of. It is a more number. This is a more number of electrons. Rate of a flow charge is called electric charge. Rate of a flow charge is called electric current. What is a flow of a charge is electric current. Continuous and closed path of electric current is called electric current. Okay. Current always follow in closed path. Yes, we know. Electrons will always follow in enclosed circuit. Number of electron contains by 1 see 1 coulomb charges is how much? This much, 6.24 multiple 10 raised to power 18. If we remove decimal, then what will be? 6 to 4, then 16 0 after 6 to 4. After 6 to 4, this much electrons are equal to 1 coulomb. Measurement of electric current. In this we have understood what meaning of electric current with one formula, and we know that 1 coulomb is equal to 6.24 multiple 10 raised to power 18 electrons, we know, and 1 electron is equal to 1.6 multiple 10 raised to power minus coulomb. Now measurement of electric current. Measurement of electric current. Measurement. Okay. Now let's also try to understand how electric current is measured. Measure with a small activity. With a small activity, with advice, how can we measure any electricity? We will use a device so that we can measure electricity. If inside a conductor electricity is flowing, electric charges are traveling, then how can we measure? But just by using devices. So let's say this through a small activity. Here we have, when you want to purchase oil and sugar, then you visit a grocery shop. Yes, grocery shop. Grocery shop. Okay. What will you ask to shopkeeper? What will you ask to shop? If you wanted to purchase rice and oil, then what will you say to shopkeeper? You would say, do you have rice oil? Then what is the quality of this? How much is the price of this? All these things you will ask to shopkeeper. You will say that I want sugar and oil. Yes, yes. But shopkeeper asks you another question. How many kg of sugar and how many liter of oil you want? Then you would say 1 kg, half kg, whatever would be your requirement. Then you will say, I want 1 kg sugar and 1 liter. 1 kg. This is how this is how shopkeeper. So by shopkeeper will give you 1 kg sugar and 1 liter oil. How? That shopkeeper will measure mass of the weight of the sugar by using a device. And same here we will use this device which will be used to measure electricity. To measure electricity there is another device from this device. To measure all this type of objects, we use another different device here. So will you measure electric current in same unit like which you used for sugar and oil? No, unit will be different for this electric current. For oil we use unit liter. For sugar we use unit which is a kg. No, because every quantity is a measure in different unit. Yes, every quantity. For atmospheric, we use unit different unit. For liquid material, we use a unique unit. For gravitational, something else. No. The electric current is expressed. The electric current is expressed by an unit called ampere. Ampere is a device. Remember, ampere is a device. This is the device we can use it to measure electric current. Ampere. Within how much time, how much coulomb have passed? this will be found out by using ampere, and it was invited by named by this scientist in this time. SI unit of a current is what? SI unit of a current is a what? This. We can say SI unit of a current is a ampere, and this is also a device, coulomb per second. This is what unit, and ampere is a device to measure electric current. Now the electric current is expressed. The electric current is expressed by a unit called ampere. Okay. We know this is a image of this is scientist. He discovered this ampere to measure electricity current. Large quantity of a current is measured in ampere. Large, whether it is a small, whether it is a more, all this current will be measured by just using this ampere. We can represent this ampere as a mathematics by using just a letter, first letter of a ampere. It will be valid. Okay? A small quantities of a current are expressed in millimeter. Hold on, in ampere, But for a small quantities of a current, we will express this in milliampere, not millimeter, milliampere, which means a small number of quantities. For more microampere, this 1 milliampere is equal to 10 raised to power minus 3 ampere, and 1 microampere is equal to 10 raised to power minus 6 ampere. Okay, this is a microampere and this is a milliampere. This is a microampere, this is a milliampere. This is milliampere, this is a microampere. Milliampere technology, and this is microampere. It looks like that. These are devices that are used to measure electricity. Now next we have defined 1 ampere. By defining 1 ampere, we will get what? We will see that this much electrons are passing within this much time. This is what we will find by just 1 ampere. Let's say 1 ampere is constituted by the flow of 1 coulomb or charge per second. That is this. This is 1 ampere. 1 ampere is equal to 1 coulomb upon 1 second. In 1 second, how much coulomb will pass? 1 coulomb, and 1 coulomb is equal to how much electrons? We know 6.28 or something. This much coulombs. So here we are saying 1 ampere, this much electric current. In this much electric current, this much coulombs in 1 second are passing. This is what we are saying just by observing this mathematics. What are we saying? We are saying this much 1 coulomb is passing within a 1 second is what? Current. We know that all these are current, but we are saying within a 1 second 1 coulomb is passing. If we have 1 ampere there, if we have 2 ampere, then this will be something else. Now we will try to understand by which instrument, ampere instrument, we will use ampere instrument, is measured in a circuit. Electric current is measured in a circuit. Hold on. Here we are going to visualize it. 1 ampere is equal to 1 coulomb upon 1 second. Let's see. Now we will try to understand by which instrument electric current is measured in circuit. Here, when we go to grocery shop, then which machine shopkeeper used to measure it at? We know, or this pattern. I don't know name of that device, but I can say that yes, this device is used to do this to measure uh, ration shops. Shopkeeper use weighing machine. This machine, name of this machine is what? Weighing machine to weigh the items. Okay. Will you use weighing machine to measure electric current? Answer is not. Answer is no. We will not use this weighing machine to measure electric current. To measure electric current, we have ampere device. No, because yes, an instrument called ammeter measure this instrument. Ammeter. Ammeter measures electric current. To measure electric current, we use this ammeter in a circuit to measure what electric current. This is the device that we are talking about here. So here this device will tell you that yes, with this is what electric current. Okay. The electrical symbol, this electrical symbol we use to represent ammeter in a circuit. This is a ammeter, and here comes cell. Unit of electric current is a ampere. We know ampere. That is ampere. Ampere is also device. Ammeter is used to measure electric current in the circuit. This device is used in the circuit to measure electric current. We will see two types of devices. First, one for voltage, one for electric current. We have seen a device for electric current. One is left. Electric current and circuit and circuit problem. We have studied about the current in previous program. Let us solve a equation based on the concept we just studied. Rate of a flow of a charge known as a current. Rate of a flow of a charge known as a current. What would you like to say here? So rate of flow of a charge known as current. Yes, we can write it mathematically like this. Here we are saying this charges is equal to Coulomb upon T. We have equation based on this. A current of 0.5 ampere. Electric current, unit of electric current is what? Ampere. So a current which is 0.5 ampere is drawn by a filament of a electric bulb for 10 minutes. It is a continue with this much current. This is continue with till the 10 minutes. Find the amount of electric current charge, electric charges. Find the amount of electric charges that follows through the circuit till the 10 minute charges. Here we are given this electric current we are given 0.5 ampere, and time is also given 10 minutes. So we can convert this in second. 60 multiple 1, although 60 second 1 minute, so 60 minute we now. So here we have 10 minutes, so 10 multiple 60 would be 600 coulomb, which means number of electrons will be how much if this much electric current is passing within this 10 minutes, then how much will be coulomb? Let's find out. So we have this formula. With the help of this formula we can easily find coulomb, number of electrons. Let's see. So we get this QIT. because from this formula we are getting this Q is equal to IT. Q IT for this is okay. Now we want what Q? We want a Q. So for Q we have Q is equal to IT. I is 0.5 and T is a 10 minute. So 10 5s are 5 coulomb. 5 coulomb. 5 electrons passed within a 10 minutes. Not we will have to convert this in second. So here we are getting how much? 6 5s are 30, 300 we can say. 300 coulomb, this much. And you know 1 coulomb is equal to how much electron? This is not a small number. When you will convert this 300 coulomb into electrons, then number of electrons will be more. It will be beyond of your thinking. This number of electrons will be beyond of your thinking. As you know, 1 coulomb is equal to 6.28, like that, something. Then multiple 10 raised to power positive 80. It is a big. But when we will multiple this number by this 300, then it will be more. You can see. So within a 10 minutes, this much 0.5 ampere passed. Okay. Now electric potential and potential difference. This is also necessary for this lecture. Let us try to understand electric potential and potential difference with the help of activity. We are ready. We are ready. We are ready. Let's see. Electric potential and potential difference. Here we have two diagrams. Imagine you have two beaker filled with equal amount of water. We have filled water. Amount of water in this is something which is the same in this. Okay, both are same. What an amount of water in both beaker are same. Clear? Now we are doing a activity, and through this activity we will understand meaning of electric potential and potential difference. They are both connected with a pipe. Yes, there is a pipe which are connected to each other with a pipe at bottom. Yes. Now what will happen? Again we will see what this level both are equal because of this is a state. But if it is like that, then what will happen? Then this level will be here in this amount of water will be less in this, like that you will see. Now we are observing that here amount of water in both are still same. If you observe two beaker for a few seconds, do you feel that water will follow from one beaker to another beaker? Yes, but not more. No, because water level in both beaker is the same. Yes, both beaker is the same. So there is no water level difference. Yeah. No water level difference. So water will not follow from one beaker to another because level amount of water in both beaker are same. That's why water will not follow in any of them beaker. Water will follow from one beaker to another beaker when amount of water in one beaker is more and amount of one water in a beaker is less, then in that case water will follow, and this will be known as potential difference. So here we are observing in both beaker we have same amount of water, so that's why it is not flowing. Now let me give you a task that without changing the amount of water in any one of the beaker. Okay. Can you make the water flow from the beaker to 2 1. Yes, we can make just in this uh, amount of water should be more, and in this should be less. Then water will follow from this into this, and it will stop to follow when level in both amount of water will become equal. Then you can see how will you do it. I have told you. I have told you. In this there is no water. There is no amount of water. In this there is a amount of water. Now this some water will follow in this water, and it will stop flowing when amount of water in both will be equal at a time, at a certain time. Then it will stop flowing. You can do it by raising the height of a beaker to once you raised height. Water will start to follow beaker from the beaker to beaker 1 to beaker 1. Height is also giving importance here. What if amount of water in both are same, but height is different? Then still in this case, will it follow? But how? In this case, have you ever thought about why this happened here? Height difference. This is known as height difference. The height difference causes a pressure difference between the water into here. This is a pressure. Here it is a pressure. Okay. To balance this pressure difference, the water starts flowing from beaker 2 to beaker 1. In similar way, there have to be some factors that make the current in a wire flow. Here, if you have a copper wire, do you think that electric current will follow through it on its own? Yes, it will follow. Here, no, because there nothing that is bringing the charge to move. Okay. So what is the factors that trigger the follow that trigger follow of electric charge? We say the term potential here. Have you heard this term before? No. Yes, we have heard about term potential energy in previous class. Potential energy is a stored energy when object is at height. Yes. We saw this meaning of this with two beakers. A beaker which was at height. So that activity was about potential energy. Potential energy, which means energy is stored. Potential energy, which means energy is stored inside the object. When it will be released, then this will start working. This is what is a potential energy. Remember, the object which has a energy, when it will be released, then it will start working. It will come into motion. Here we have example. In our hand there is object. We can say it is a ball. Now it gained energy and it is at a height. When it will be released, then this ball will come into motion. When it will come into motion, then this type of scenario, this type of view will be. So here we will say this is a kinetic energy when it will come into motion. But still it is a what? Right now it is what? Potential energy. Inside this is a potential energy. Potential energy. And it is at height, that's why. That's why. And when this will be released, then this will come into kinetic energy. Here, it came into kinetic energy. And when you drop it, potential energy converted into the kinetic energy. Remember, energy cannot be destroyed. Energy is cannot be ended. It can be converted from one medium to another. It can be only converted. Now, electric potential energy. Similarly, there is a concept of electric potential energy. Electric potential energy. Just like ball in your hand has a high potential energy, similar negative charge close to another negative charge has a high potential energy. Here what is happening? This height, it will have more potential energy, high potential energy close to. So this is a more height, then it we can say this is a high potential energy, high potential electric energy, electric energy. This is a low potential energy and this is a high potential energy. When it will come to this proton, then this will be low potential energy. When it is to the when it is to the another electron, then it has, and if it has a height, then it will be it will have high potential energy. Here, let's read this. It if left free If left free, negative charge gets replied by another negative charge. Negative charge. Because both are same. Both are same. So both will repel to each other. Now here we have this plus and both are different. So both will attract to each other. Both will attract to each other as we know. So and here we can see there is a height between them. So here at this it is gaining more potential energy. When it will come into motion, then here this this process will be this process will be kinetic energy, and at the end it will have low potential, no end, low potential energy. So this process is a kinetic energy and it will be here, so it is a high potential energy. It just converts into high and low into high, high into low. Just it converts. It converts. So tell you, positive charge just like a ball falls towards, just like a ball falls towards the earth. As you know, this happens because of a gravitational force. Gravitational force is an attraction force. All the objects attract to each other in the earth. We know we are. What is the potential difference? We are crystal clear about the potential energy. Okay, but what is the potential difference? It is the electric pressure. It is the electric pressure between 2 points. Between 2 points. It is the electric pressure, electric pressure. Between 2 points, this difference may arise due to cells. It is also referred to as a voltage. Here we have this positive terminal, this negative terminal. In this we can see this type of two terminals. Now, what are we understanding by this? Here we have this figure. This is circuit. This is bulb. This is okay. We didn't understand it still about a potential difference. We define the electric potential. We define the electric potential difference between 2 points. We define the electric potential difference. We define the electric potential difference between 2 points. We will have to take 2 points in any electric current carrying some current as the work done to move a unit charge from one point to another. Here we have this. this and this. Here, what can we see? We can see pressure. Where would be more pressure? So of course here would be more pressure. Here, here would be less pressure. So there is a difference between them. This would be potential energy. Potential difference, it is represented by V between 2 points. Potential difference is equal to work done upon charge. Upon charge. It can be also represented by W upon Q. Unit of a work done, it is represented by it will be represented by W, and charge will be represented by Q. W, which here unit of this work done is the joules, and unit of energy is also joule. Unit of a charge is a coulomb. Remember, potential difference is equal to work done. Potential difference, yes, this is the formula to calculate a potential difference, or to calculate the work done, or to calculate charge. The SI unit of electric potential difference is a volt. Okay, named after, yes, okay, this is the history. This is the history behind it. Potential energy is equal to potential difference, not energy. Potential difference. Also, always remember, always over where we are taking difference. Suppose we will subtract something from another thing. So we are saying that yes, we will take 2 points in the case of electricity. 2 points where these 2 points will be taking what will be placed where electrons will be traveling. So what will be difference between them? This is what potential difference. Clear? Now volt. This is a history about this scientist. I am not ignoring, but if you have a freedom, then from your heart you can read it this history. And who is this? So he is a scientist, and you can read it. This is for you. Here, 1 volt is the potential difference between 2 points. Yes, in a circuit carrying conductor, when a joule of work done is to move a charge of 1 coulomb from one point to other. Okay, okay. This is a it is more. Here we are saying 1 voltage is equal to 1 joule upon 1 coulomb. This 1 voltage is equal to this much. When 1 joule of work is done to move one charge of 1 coulomb, when it will be done, then it will be moved to 1 coulomb. So this upon this will give us 1 volt. Okay. Now we will try to understand by which instrument electric potential difference is measured in circuit. So here something else a device will come, not ammeter. For measuring electric potential difference, we use a device which name is. When you go to shop, then which machine does the shopkeeper use to weigh the item? This weighing machine. Okay. Will you use weighing machine to measuring electric potential difference? No, still no. No, because it is for something. So the potential difference is used by means of an instrument called voltmeter. Voltmeter. This voltmeter is used to measure electric potential difference. Clear? Electric potential difference. Work done in moving a charge from one point to another point is called potential. Work done in moving one charge from one point to another point is called potential. Unit of electric potential is volt. Voltmeter is used to measure potential difference across 2 points. Now we have questions. This is for you. Electric circuit diagram. This is a diagram of electric circuit. Yes, Vinod. We know that circuit diagram. Here, this is bulb, this is one terminal, this is another terminal. It has also two terminals. This one. Here, this is a switch, and it is a well-connected circuit. So this is closed circuit. It will work when this switch will be on on. Then here in this video, we will learn about electric symbols of electric components. This is for you. Here we have ammeter, this is voltmeter. It is used to measure electric current, and this is used to measure electric potential difference. This collection of batteries for a this collection of electric cell for a battery. This is bulb. These are electric components. It is often convenient to draw a schematic diagram in which different components of the circuit are represented by the symbol conventionally. Okay, we now this is also done. So we have this two electric cells. This electric cell has how much voltage? 1.5, and this also 1.5. When we will combine this both, we will get 3 volt. 3 volt when we will combine this. So we can say this much voltage we will get by combining these two cells in proper connection. Do you recognize this? What do you call it? Yes, you recognize it. This is electric cell, we know. This reason, it is what? Positive terminal, and this is also known as metal cap, and this is a flat metal disc. This sign are of negative terminals. On the opposite side, negative terminal. How will you draw symbol of a cell? So cell, like that. I think so. Like that, yes. This a small will indicate about negative terminal, and this big will indicate about positive terminal. Okay. Now join then now it will form a battery which will give 3 volt. Now it is called a now is it called a battery? There is a collection of cells, then it will form battery. Battery also has a two terminals. Battery is a combination of two or more cells. Can you draw the symbol of a battery? Yes. This is symbol of a battery. This will be symbol of a battery. Now, which electrical component do you use to on a switch? This switch work of this switch is to break the circuit, closed circuit, or complete the broken circuit. How many components does this circuit have? So this 1, 2, 3, 4, including wire. This circuit has a 4 components, including wire. 3 a bulb, switch, cell, and what about wire? Wire is also component. Okay, this is done. This is also done. What is the symbol of a switch? This is a symbol of a switch. We have two symbols for a switch. On and off. This is a on and this is off. This is off, this is on. All this is for you, okay? All this is for you till now. Somebody is calling, but this is enough for you right now. We will cover all these left topics in separate lecture.